Let's talk about another aspect of integration. This aspect of integration is when we have something that is a little bit harder and not really recognizable. And so what we're going to do here is we're going to use a process called substitution, or sometimes it's called change of variables. You will probably use this in almost every integral you do from here on. So let me show you an example. This is integration by substitution. So here's what it is. For example, what we've got is, say we've got this, x to the third, and then inside parentheses, we've got x to the fourth plus 3. And let me just make this extreme. So I'm going to say it's to the 21st power. Now we do not have the right to deal with multiplications in integration unless it's a formula we already have a value for. So we can't do that. What you might notice is that you could multiply it out. Now I made this so wild that you can't multiply it out easily. I mean, who wants to do a binomial to the 21st power? You could, and it would work. It would be just fine, but that's not what we're dealing with. So what I want to do is I want to notice that x to the fourth plus 3 in here has a derivative of 4x to the third, which is super close to this. Let's look at the process. Now, the process of substitution is threefold. First thing that you're going to do is you're going to choose a value for u. Now, u is not important, but most people use u substitution. So choose u. That is a part of this problem that we can differentiate. Then we need to find du. So the second part of this is find du. I'm going to show you that. The second thing we need to do is we need to put this stuff back in an integral, and we need to integrate based on u. The third thing we do is we put the variable x, or whatever variable we had, back in. So it's called back substitute. Now I'm going to show you this with this problem. So these are the three steps we're going to use. The thing that I want to do is I want to take the function part here that has a derivative within the problem and call it u. So with my example, I'm going to let u equal x to the fourth plus 3. Now, as you practice this, you will get better at choosing u. So then, by the derivative information that we have done before, we're going to take du dx. Du dx is equal to 4x to the third. That's the derivative of the u equation using x as the variable. Now there is a process that looks like multiplication. It is not, but it looks like it. And what it does is it tells us that we need to stick this value up here. So now we've got du is equal to 4x to the third dx. We need to put this information in our problem. We cannot have any x's in our problem. So we take this problem, which is x to the third times x to the fourth plus 3 to the 21st dx, and we substitute. X to the fourth plus 3 is equal to u, so I'm going to put u in there. So I've got x to the third, and I've got dx left. The 21st power, no problem. But x to the third dx. Well, here I've got x to the third dx. I've got 4 of them though, so I need to divide by 4. Cancel that out. And so these two equal du over 4. So here's what my problem becomes. It becomes u to the 21st power du over 4. Now I'm going to send that out in front, so I'm going to call this 1/4 the integral u to the 21st du. Now this is a facsimile of this problem, but it's really easy. This one's not. So our goal is to make a hard problem look easy. This is a power problem, so we're going to use the reverse power rule. So let's go ahead and integrate. We've got 1/4. We take u to the 21st plus 1 over the new power, 21 plus 1. And this is an indefinite integral, so we're going to say plus c. Now we've got 22. So 4 times 22 is 88. This is u to the 22nd plus c. So we just integrated. That wasn't too hard. The last step we have to take is we have to put this back substitute. So we have to put x's back in place of u. Well, what is u? U is x to the 4th plus 3. So this is 1 over 88 times x to the 4th plus 3 to the 22nd plus c. That's all it is. The key is choosing the right value for u. So let's try some more examples. The next example that I have is this one. It is example 2, say, it is the square root of 3 minus 4x squared multiplied by minus 8x, so 8, dx. Now, my idea of looking for u is to look for something that's complicated and usually under a root, a power, in a denominator, part of an angle of a trig function. So it's complicated and kind of stuck somewhere. Well, here's the deal. I like that one. So u is 3 minus 4x squared. In this case, that's what I'm going to choose for u. I'm going to take du dx. That gives me 0, and then 2 times minus 4 is minus 8x squared, or minus 8x. So then I move this over. I'm going to stop doing this in 2 steps. Notice this and this are identical. So then we substitute. So we've got the square root of u. Notice I did not take the square root. I just took the complex stuff that was underneath it. Here I've got du. So we put this in powers. U to the 1/2 du. Well, the reverse power rule tells us we can take 1/2 plus 1, that power, divide by the new power, and add c. So this is 3/2. This is 3/2. What I'm going to do is I'm going to call this 2/3 u to the 3/2 plus c. So I just took the reciprocal of that and multiplied it. Now back substitute. 2/3 u is 3 minus 4x squared to the 3/2 power, and then plus c. If you want it exactly the same style you started with, here's what you can do. You can say it's 2/3 square root of 3 minus 4x squared to the 3rd plus c. And you could simplify using a little more algebra if you want. But that is the integral. We chose u. We put everything in the problem in terms of u. We integrated. Then we did what's called back substitution, put the x's back. Let's look at another example. Get a clean sheet of paper for another example. So here's my next example. So this is example 3. This one is 1 plus 1 over t to the 5th times 1 over t squared dt. So this one has to do with the variable t. Well, what do you think the most complicated thing is? Again, I like to choose u to be something that is kind of stuck under a power, a root in a denominator, as an angle of a function or a trig function, something like that. So in this case, I'm going to choose this. U equals 1 plus 1 over t. Or if we want, we could call it 1 plus t to the minus 1. So then I need to get du dt. Well, I'm going to just do this. Cut one of the steps out. So du, I'm going to take the derivative of this. This is 0. This one is minus t to the minus 2. Then I stick the dt. Now I just saved it one step, that's all. This is minus 1 over t squared dt. So that is du, and here's u. So we have to substitute. Now you've got to get rid of every evidence of t in this whole problem. So here's what you do. You write 1 plus t. Oh, 1 plus 1 over t, that is u. So we've got u to the 5th. Now 1 over t squared dt. We've almost got that. We've got minus it. So actually d minus du is equal to 1 over t squared dt. So this is minus du. I'm going to pull the minus out here, so I don't really need to deal with it. It's a minus 1. So here's my problem. Now this one looked hard. This one is just a reverse power problem. So we've got minus, then u to the 6th over 6 plus c. Just add 1 to the power, divide by the new power. So the integration is relatively simple. Now we have to go back and put the t's back in. So here's what we've got. Our answer is minus. U is this, so 1 plus 1 over t to the 6th power divided by 6. Okay, so instead of getting a complex fraction, I'm just going to put 1/6 there, and then plus c. So there's our final answer. Really goes fairly quickly. Now, I, of course, love trig examples, so we're going to have a trig example next. My trig example is this. I've got the cosine cubed of 2x times the sine of 2x dx. Now, 2x as an angle could be done or worked on with trig identities, but I'm not going to do that with this one. I'm going to just flat out use substitution. So what's complicated? Well, there are a number of things that are complicated. 2x as an angle is complicated. The cosine cubed of 2x is complicated. The sine of 2x, not quite as complicated, but I notice that I've got a trig function, cosine 2x, that's all cubed, and it's pretty complicated, and I've got a sine of 2x, that's the derivative of cosine. It's got the same angle, so I'm going to use that. I'm going to use u equals the cosine of 2x. So I didn't just use the angle, use the function too, because the function is locked under a power. So I've got actually u cubed here. So if I take the derivative du, I've got to take the derivative, this is a chain rule problem, so derivative of cosine is minus sine of 2x multiplied by the derivative of the angle, which is 2, and then I'm going to throw that dx. I'm shortening my work a little bit. I've got to replace things in the problem now. I've got to substitute. So cosine cubed, this is u cubed. There's no trig in that at all. Now, this has to take care of all of this, because that's what's left. Well, I've got this, and I've got this. So I need to get rid of the minus and the 2. So let's divide this by minus 2. So we end up with du and then over minus 2. Here's a slick way to do that. You can call it minus 1/2. Then we do the integral. So you don't even have to do a trig integral here because this is just a power rule. U to the 4th over 4 plus c. So we end up with minus 1/8 u to the 4th plus c. Then we do back substitution. So let's back substitute. If we take minus 1/8, what's u? U is cosine 2x, so I've got cosine 2x. Got to raise it to the 4th power because u is to the 4th, and then plus c. Now an alternative way to write that would be minus 1/8 cosine to the 4th of 2x plus c. So there's your answer. I hope that helps you do a little bit of substitution.